Hi, I am Charmaine and I'm from D4.
To kick things off, let the velocity of the rain be VR and the velocity of the car be VC. So let's start at when t equals to 0. At t equals to 0, your VC is 0 and the angle is 45 degrees, according to the question. By looking at this triangle, your VC is the horizontal line and your VR is your vertical line. After subbing in your angle, you figure out that it's a right angle. And you can apply trigonometry. Since VC is your adjacent and VR is your opposite, you can use tangent rule. VC at t equals to 0 equals to VR tangent theta, which is also equals to VR tangent 45 degrees. If you use your calculator, tangent 45 degrees equals to 1. So VC equals to VR. And earlier on, we have solved that VC equals to 0. Therefore, VC equals to VR equals to 0. But it is technically impossible because the rain cannot stop mid-air. It will have to fall due to gravity. Let's move on to when t equals to 2. At t equals to 2, you can use this formula A equals to V minus U over t. In this case, your u, which is your initial velocity, equals to 0 because at the start when t equals to 0, your vc equals to 0. So, the question also states that acceleration equals to 1.3 meter per second square, and it is over the duration of 2 seconds. vc equals to at equals to 1.3 times 2, which will give you 2.6 meter per second. The question also states that the angle changed from 45 degrees to 60 degrees. With the increase in angle, it is still a right angle, as your VC is still your horizontal and your VR is still your vertical. So by drawing out the same triangle like we did earlier, with just a change in angle, you can still apply trigonometry. VC at t equals to 2 equals to VR times tangent theta, which is VR times tangent 60. If you type inside the calculator, tangent 60 will give you square root 3. In the end, you'll get VC equals to square root 3 times VR. Since we have solved that VC equals to 2.6 meter per second, you can sub it in as VC equals to square root 3 VR, which is also equals to 2.6. Now, let's compare the change in velocity of the car. To find the change in velocity of the car, it is the velocity of the car at t equals to 2 minus the velocity of the car at t equals to 0. Since you have the values, square root 3 VR minus VR, which you can also rewrite it as VR bracket square root 3 minus 1 bracket. Since the change in velocity of the car can also be found as 2.6 minus 0, which is 2.6, you can sub in both equations to find your VR, where 2.6 equals to VR bracket square root 3 minus 1 bracket, making your VR the subject. 2.6 divided by square root 3 minus 1, in the end you'll get 3.55 meter per second. Moving on to part B. So according to the question, your angular velocity is 3.14 radian per second, your radius is 5 meters, mass of Mr. X is 100 kg, and pi equals to 3.14. So for part 1, you can use the formula angular velocity equals to theta over time. Since they're asking you to find the time for one revolution of the Ferris wheel, one revolution equals to 2 pi radian. So by subbing in the values, t equals to 2 times bracket 3.14 bracket over 3.14. You can cancel both 3.14 from the numerator and the denominator. In the end, you will get the time span of 2 seconds. For part 2, since we have the value of the angular velocity and the value of radius, we can use the formula angular velocity equals to the linear velocity over radius. So after making v your subject, you can sub in your values, which is 3.14 times 5. In the end, you'll get 15.7 meter per second. For part 3, they're asking for the centripetal acceleration of each passenger. So if you don't know what a centripetal acceleration is, it it is the acceleration that is directed towards the center of the circle. So in this case, you can use the formula A equals to V squared divided by R. Since you have the value for V earlier on at part 2, and you have the value of R which is 5, you can sub in the values, which is 15.7 squared over 5. In the end, you'll get 49.3 meter per second squared. For the last part of the question, which they're asking you to find the force which the cubicle exerted on Mr. X when he's at the bottom of the Ferris wheel, you can use this general formula F equals to ma, where m is your mass and a is your acceleration. So, firstly, you will have to find the weight of Mr. X, which is, using the formula, 100 kg times 9.6. And then, you will have to add an additional force which is called the centripetal force, which is the force that is directed towards the center of the circle. You will have to add both of his weight and the centripetal force because this is the force needed to overcome the weight and the centripetal force in order for the wheel to move up again. So, by applying the equations, mg plus ma, and earlier on, you can find out that A equals to V squared over R. So you can sub in the new equation, which is mg plus m bracket V squared over R bracket. After subbing in the values, 100 times 9.6 plus 100 times 49.3, in the end you will get 5,910 Newton.